us examples. Sure. Let me find a good eraser. So I'm going to write down one example from elementary calculus and a new example for multivariable calculus. So you can compare these two. So this is example as a review. So suppose you have function y equals to square root of x plus 1. I ask you, what is the domain of this function? Domain of the function. Well, going back to algebra, guys, it's not even calculus. Going back to algebra, we have the following scenario from algebra. Since you have a radical and it has even index, x plus 1 must be larger than equals to 0. So since we have a radical, x plus 1 must be larger than equal to 0. What's the meaning of that? It means that x is larger than equals to -1. What's the meaning of that? It means that the domain is on x-axis, as you remember, and it takes on values larger than or equals to -1. So here you have -1, and you shade all values on the right-hand side. This is the domain. In interval notation, the domain can be written as the interval -1 to +infinity, or you can say that, hey, the domain is the set of all x values such that x is larger than equals to -1. Okay, this is just a very easy example for you. Now we're generalizing the idea, we're introducing some new contents. Suppose I ask you, hey, for function z equals to square root of x plus y plus 1, what is the domain? Well, okay. First of all, this guy is a two-variable function. Two-variable function. Okay. Remember the definition. By definition, the domain is equal to the set of x comma y's. D, or the domain, is the set of x comma y values such that, with the condition that, well, there are some conditions. We have to remember, we have to review what we learned before. We know that if we have a radical, the quantity inside the radical, whatever it is, must be larger than equals to 0. It satisfies in multivariable functions as well. There's no difference. As long as you have a radical, the quantity must be larger than equals to 0. X plus y plus 1 must be larger than equals to 0. Okay. So what is this? It says, hey, I have all points in the plane such that, with the condition that if I add x and y together plus 1, it is always larger than equal to 0. You have an inequality. Okay, inequality, where I have learned about inequalities. Oh yeah, algebra. It's just pure algebra. So it says, from algebra, if I ask you to graph this, you can easily visualize it. Guys, again, note that I'm just talking about the domain of the function. I'm not visualizing z. I'm just trying to visualize, analyze, understand the domain of this function. Okay. So x plus y plus 1 is larger than or equal to 0. To graph this inequality, you can say that, hey, I have x plus y equals to -1, or y is -1 minus x. If you plug in 0, your y is -1. If you plug in, for example, -1, then you get 0. So this is this line. All right. And then if you use, for example, a point, checkpoint, like the origin, 0 plus 0 plus 1 is always larger than or equal to 0. So since it's including the origin, the checkpoint like origin, you're going to shade the top of the line. These are all points. These are all these points that x plus y plus 1 is larger than or equals to 0. This is the domain of this function. All of these points above the line. Now remember that this is just -1, and this is just -1 and 0. Okay, perfect. So we just visualize the domain of this function. How do I visualize the function itself? Well, we're going to use many free 3D visualizer that are available for us. So let us try to visualize this. What do we have here? We have many different websites, free websites that we can use to visualize the two variable functions. For example, we can use, let me see, math3d.org. So here you can graph this function, and you have different options here. You can add the object, explicit surface, you can graph implicit surface. That depends whichever you feel more comfortable, or which formula do you have here. Here I have z equals to, well, I have square root of, so let me write down a square root of x plus y plus 1, and just get rid of this. And erase these. Here we go. So this is a rough sketch of this object that you have. Well, you can increase the scale, for example, to 7, and have more visualization. You can use Desmos, 3D graphing, not the help center. Very good. Here you have GeoGebra that you can use. You can use Desmos. Let me see. Here we have z equals to square root of x plus y plus 1. So they're all amazing, free online graphing websites available for you. So this is this object. The reflection of this object on xy plane is the one that we graphed on the board. So take a look at the board. On the board, you have the domain in xy plane. But to visualize this in the space, to get this object, you have x, y, and z. So the reflection of this object, this surface in xy plane, is the domain of the function. For the range, as you can see, z starts from 0 and it goes to positive infinity. So for the range, You only look at the z-axis, right?